Chord. All right, so today, arithmetic sequences. Arithmetic sequences, well, first, sequences are an ordered list of numbers, right? We just talked about that before the recording, so my bad. Sequences are an ordered list of numbers. It's an ordered list. An ordered list. Arithmetic sequence is that ordered list, so I'm just going to write sequence again. It's a sequence in which the difference, I would underline difference, between two consecutive, does somebody know what consecutive means? Consecutive, I think that's how. Consecutive, I'm horrible at spelling, sorry. Consecutive, that means like one right after the other. Consecutive. They're right next to each other. The order, consecutive. C-O-N-S-E-C-U-T-I-V-E, I believe is how it's spelled. I'm a math teacher, not a spelling teacher. Consecutive terms is the same. So the sequence in which the difference between the two consecutive terms is the same. The difference between two consecutive terms is the same. For it to be arithmetic, pretty much what this is saying is you must add the same number each time. Has to be a constant rate of change. So that's what an arithmetic sequence is defined as. And we have two forms. We have two forms of sequences. We have explicit. We have an explicit form. Our explicit form is A sub n. A sub n, that's kind of just a label. That's saying my value at the nth term equals A1 plus parentheses n minus 1. Hold on, guys.
You're scaring me right now.
We're going to explain what each thing is. That's A sub n. A sub n equals A1 plus parentheses n minus 1 parentheses times d. Where? This is our first term in the sequence. This is the common difference. So that's explicit form. Explicit form. It may not make complete sense until we look at an example, but we're building the foundation of what kind of the definitions are. We're kind of building the foundation of the definitions. So that's explicit form. Then we have, I need conversation to be at a level 0. And we have recursive form. Recursive form is kind of interesting. It's actually two different statements. It's 2 statements. Almost a list of statements. So usually you see it with this little fancy bracket that I can never draw, ever. Horrible at it. And usually what it is it says A1, and it tells you the first value, the start value. And then, just like the other one, you're going to give a formula, or what we call those is the general rules. And then we use the general rules for the sequence to find the missing term or the desired term. So our formula for the recursive form is AN equals A sub n minus 1. All of that is underneath plus D. So let's talk about what each thing is. Let's go down here. A1 is the first term in the sequence. AN, or A sub n, is the term we're trying to find. A sub n minus 1 is our previous term. And D is our common difference. Okay, so that's pretty much all of the notes that we're going to take. We're going to do one example, and then we're going to work on some of the practice problems, which are now posted here in a second. But it seems very complicated. Does anybody have a feeling what we've talked about before with the constant rate of change or a common difference? Where have we heard that before?
Linear nonlinear fractions.
Exactly, linear equations, right? All this is just another way to look at a linear equation. Sequences seem very complicated. If you struggle with it, I promise you, I understand that. It probably took me until halfway through last year for sequences to actually click. Sequences are difficult, and I understand that. My job and my goal is to help you make them not so scary. So, are we ready to go on to an example? Does everybody have this written down? I heard several no's. I'm going to give you about 30 more seconds. Actually, I'll give you a little bit more time while I do attendance. Do what? Well, that's unfortunate. Where did I put that? Because I definitely moved it. Oh, I forgot to put it in the folder. Give me just a second. It was just on the main homepage. Okay, it should be there if you refresh it. Okay, so let's do a quick example. Quick example. This is not on the practice. This is just Okay. Example. I'm going to have the sequence. There's the little bracket thing. So that's our sequence. We're going to want to find our problem is find the 10th term. Find the 10th term. First, we're going to do it in explicit, and then we'll do it in recursive. Yeah, we'll do explicit first. Actually, before I go into that, I want to talk about pretty much our 2 steps. We have 2 steps to do this. First, we're going to find the general rule. General rule. And what that is that's taking our recursive form or our explicit form and substituting in what we can find out or what values we know, like our A1 we should know, and our common difference we know. Then step 2 is to find the term that we want. So there's kind of 2 steps that we're going to be doing on this. Looking at 100 to 107, what did I add? I added 7. Okay, 107 to 114. 7. It's find the term. Plus 7. So what is our common difference? Our common difference is 7. What is our A1? What's the first term? 100. So let's talk about our explicit, if we're going to find using the explicit. Explicit, that equation is A sub n, the term we're looking for, equals A1 plus n minus 1 times, oh, I'm sorry, still doing D. That's the equation for our arithmetic, our explicit form for arithmetic sequences. There is another type of sequences we're going to talk about, but we'll talk about it in a different unit. So we know 2 of those values. What do we know? A1 and D. So A sub n equals, what's our A1? 100 plus n minus 1. What's our D? 7. This is the general rule for this sequence. You see, we just substituted in what we knew. We just substituted in what we knew. Now, so we've done step 1. Now we need to do step 2 and find the term that we want. We want what term? We want find the 10th term. So we want n to equal 10. We want n to equal 10. We want the 10th term. So to solve for that, that would look like A sub 10 equals 100. What I'm doing is everywhere there's an n, I'm putting 10. Everywhere there's an n, I put 10. All right, in the parentheses, because we're going to do our PEMDAS, our order of operations. What's 10 minus 1?
9.
What is 9 times 7? So 163 is our a sub 10, or our 10th term. That's our 10th term. That's kind of, if we didn't understand what each part was, then this part would be confusing. So that's why we have to look at the definitions and kind of build the foundation. And so then when we do the example, all we're doing is a little substitution in order of operations. Now, recursive form. Let's talk about recursive form. Recursive. Remember, that's the kind of the list. So I'm going to write it real small. That's our A1 equals, and then our AN equals A to the N minus 1 plus 7. Or plus D, I'm sorry. I'm putting in our general rule. So step 1 would find the general rule. General rule for recursive form. What was our A1? 100. And then A sub N equals A sub N minus 1 plus, what was our D? I want to make sure. I feel like my plus is a little low. Plus 7. So that's the general rule. Now, this is where you're going to really start to love explicit form. We want to know what A sub 10 is, right? We wanted the 10th term. The only way we can find it with recursive is as long as we have our previous term. So I'm going to need A sub 9. Well, to find A sub 9, what am I going to need? A sub 8, A sub 7. So what you'd have to do is, so we know what A1 is. So A2 equals A1 plus 7. So that would be 100 plus 7. You can go on and on. If you have to do it in recursive form, start with your last value. What value is that? What number in our sequence? That's 4, right? 1, 2, 3, 4. 1, 2, 3, 4. Sorry, that's really delayed and really not cute writing. So 100 is our first term. 107 is our second. 114 is our third. 121 is our fourth term. So that means that A sub 4 or A sub 5 equals 121, our previous value, plus 7, which equals 128. Then A sub 6 equals 128 plus 7, which equals 135. So you would have to do all of the work until you got to A sub 10. Explicit is my favorite. Explicit will easily become your favorite.
Oh yeah, I think that's better. You have to like put in a
So that's the end of our notes today. I am going to work on some practice problems. So I'm going to, let's pause the recording, right? Recording again now? I think so. Okay. So now that we're looking at the practice document, we're going to determine if the sequence is arithmetic. If it is, we're going to find the common difference and the next 3 terms in the sequence. So for it to be arithmetic, it has to have a common difference, or adding the same number each time. It has to have a constant rate of change. How did I go from 35 to minus 3? Okay. 32 to 29. 29 to 26. So is it the same number each time? Yes, we're adding a negative 3, or we're subtracting 3 each time. So our common difference is -3. So yes, it is an arithmetic sequence. It is an arithmetic sequence. So our D is -3. So with this one, which one do you think is easier to use, recursive or explicit? I would take a more generic of the recursive and just say, okay, what's 26 minus 3? 23, what's 23 minus 3? 20, and then what's 20 minus 3? So sometimes it is quicker to use the recursive form, as in we're going from the previous value in the sequence, applying our rule, which is our common difference, and going on and on like that. It's a complicated way of just saying do the math. Now, if I have the first 5 terms and I want the 100th term, which one's going to be the one you want to use? Explicit, exactly. If it can take you directly to that sequence or that value, then I would go there. Okay, let's see. -3 to -23. -20, okay. What about -23 to -46? Do we have a common difference? It is not an arithmetic sequence. We're not at an arithmetic sequence. Yeah, I mean, if it's not an arithmetic sequence, there's nothing we can do about it. I'm gonna let y'all finish those. I mean, I think this is a lot easier than it looks. Like, it seems like it's really scary because there's lots of new vocabulary. There's lots of new ways to look at this. But it's really just substitution in a unique looking linear equation. Okay, so on number 7, you are given the explicit formula of an arithmetic sequence. Find the first 3 terms and the term named in the problem. Oh, this person does it in the weird way.
That's weird.
N-1. We might skip that page. You won't get to see it like this. Just ignore that section. I mean, I have you the answer key, so it's not like you're really struggling. But okay, you're given the first term and the common difference. So when the answer key, I guarantee you this person, I apologize. I found this like when we first started this unit, and I forgot to double check it. Given the first term and the common difference for an arithmetic sequence, I'm sorry. We need to be working on this. Thank you. So we're going to find the explicit formula for this. So our explicit is A sub n equals A1 plus n minus 1 times D. N minus 1 times D. That's our explicit formula. So what's A1 then? Give it. It's 28 plus, we don't know what our N is, times 10, right? So our explicit formula is A sub n equals 28 plus n minus 1 times 10. So what probably on the key, when looking at it, they're going to be like this. What they did is they took our explicit form and they distributed the 10 and then combined like terms. But what we're using, this is what we need to see. So if you're having to figure out what the key is, if you want to do the math, distribute and then combine like terms. So, all right, the first 3 terms. The next 3 terms. I'm going to write the next 3 terms. Nope, it says the first 3 terms. So we know the first term is 28. And we know our common difference is 10. So what, do we really even need to put it in the explicit formula? What's my second term? You're given the first 4 terms. Okay, so look at 15. What's our common difference? How did I go from 3 to 8? How did I go from 8 to 13? Plus 5, right? So my common difference is 5. What's my A1? 3. So I have A sub n equals A1 plus n minus 1 times D.
That's a lot.
So what's my A1?
3.
3 plus n minus 1 times 5, right? That's our explicit formula. Now we want to find A20. We want the 20th term. So we want where n equals 20. Where n equals 20. So if n equals 20, everywhere there's an n, I'm putting 20. It's a subset or a subnumber, which is more of a label. So what's 20 minus 1?
19.
What's 19 times 5?
Yes.
I wonder where I could figure that out very quickly, like my calculator that I have on my computer.
What was the question? 95. I said it first.
So 820 equals 3 plus 95. So what is my... Okay, is there another page? That's all of the practice problems. So, question, how you can be asked on the test. They might give you A sub values. And you'll need to figure out what the common difference is. There's lots of different ways that they can provide this question, but just know that you're looking for a common difference. Is it adding each number or adding the same number each time? And then what's my first term? Put it in either explicit or recursive. So that is all I'm going to work on with you. I will go ahead in just a second and post our independent activity as well, so you can go ahead and start working on that if you would like, or continue working on the practice.